So now I'm going to demonstrate how to use the fast Fourier transform function on the analog discovery 2. This is a function within the oscilloscope, so we will start out there, opening up a scope workspace. I'm going to disable channel 2, and I'm going to show you just what we have, what we're outputting now. So the way I have it all set up is that the oscilloscope channel 1 input is on the waveform generator output, and in this case I have the waveform generator outputting a amplitude modulated wave for reasons that will hopefully become clear soon. We can see essentially what we have is a sine wave shape, and inside of that sine wave is another wave where at the peaks of our carrier wave the amplitude is large, and at the middle point of the carrier wave the amplitude is small. So this is what we see on our oscilloscope output, and now we want to do some analysis on it. Particularly we want to know what kind of signals make up this wave. So what we'll do is we will use the FFT function in the oscilloscope on the AD2. So we'll just come up to the top, click FFT, and we have our fast Fourier transform output. The vertical axis is in decibels, and the horizontal axis is our frequency domain. So we see a lot of noise down here. We see that's like minus 100 dB, so that's extremely small. And we mostly want to zoom into the section where there's peaks. So what we can do, we can just drag our FFT window down here at the bottom and see where these peaks are. So if we double click, we'll get sort of a measurement cursor, and we can look at the first peak is here at right around 100 Hertz. So part of this signal is at 100 Hertz, and it's going to be the carrier wave here, just the main sine wave. We have two other peaks, one at 0.9 kilohertz or 900 hertz, and another at 1.1 kilohertz. So what that tells us is that we have a 100 hertz carrier wave, and our signal in here is at 1 kilohertz, and that's because these waves are centered around 1 kilohertz and offset by the frequency of the carrier wave. So if we disable the signal here in our oscilloscope, in our the wave we're analyzing, if we hit run here, I can go and disable the amplitude modulation, and then we get a simple sine wave. If we do a FFT on this, we'll see now just a single peak through the whole frequency spectrum, and that peak is at 100 hertz all on its own. So this is a single 100 hertz sine wave. We can obviously do the fast Fourier transform with all kinds of different waveforms and shapes, and experience different results from those inputs.